Hello everyone, in this video I am going to demonstrate FSK modulation and demodulation techniques in a transceiver. So as you can see here, this is my setup, and here you can see Arduino Uno is sending alphabet R continuously, and this is my modulator part, and here is the demodulator part. So as you can see in the modulator part, there is an optical isolator. This optical isolator is isolating Arduino Uno data from the modulators and demodulators. So after the isolation, optical isolation data is fed to this transistor, and here it comes to this modulator. In the modulator, it is generating two different frequencies. So as we can see here, in this setup, it is generating two different frequencies. Please watch my previous video for the modulator. The modulator itself is very clearly explained in the previous video. So after the modulator, from the pin number 3, we are getting the real FSK signal. The main FSK signal is fed to this power MOSFET, and this power MOSFET is finally driving this transformer coil. You can see this transformer coil. So this transformer coil is having 3 windings. One winding is used to couple the power to the transformer, and there are 2 other windings. One winding I have kept spare. This winding will be used for a future use on the transmission line, and the other winding is the receiver winding. You can see here. This is the receiver part, and the other winding is connected here. You can see one wire is connected here, and the other wire is connected to the ground. So as you can see here, this is the low pass filter. You can see this resistance and this capacitance. They form the low pass filter. You can see 4.7K and 0.01 microfarad. This forms the low pass filter. The output of the low pass filter is fed to LM324 comparator IC, and after the comparison, finally the data is again compared with a voltage divider. So after the voltage divider final comparison, we are getting the final data with a single frequency. See here we were having 2 different frequencies denoting logic 0 and logic 1. Now after this LM324, the final output is having only one frequency. So that is the final data. So that data can be easily analyzed, and we can easily interpret the logic 0 and logic 1 states. Let us look into the oscilloscope waveforms. It will be clear. So as you can see, this is the oscilloscope waveform. You can see, so here you can see there are 2 different frequencies. This is the high frequency and this is the low frequency. Here again high frequency comes, low frequency. So data is encapsulated inside with 2 different frequencies. One frequency is denoting logic 0 and the other frequency is denoting logic 1. So after the demodulator, you can see it is having only one frequency. It is a single frequency, and wherever there is a logic 1, we are having a space here. So wherever there are spaces, it means there is a logic 1. You can see here there is a logic 1, here there is a logic 1. So like this, the final demodulator output is obtained. So now let us zoom the waveform again further, and it will be more clear. Here you can see this is a high frequency component here. Here is nothing. So this is filtered. See, this high frequency is filtered by the LPF low pass filter, and we are having only one frequency component here. So in the next video, I am going to finally again process this output, and we will be getting a true 0 and 1 output. So this is how we can see. This is the intermediate circuit where we can see only one frequency is available and the other frequency has been filtered out. So in the next video, I am going to have a real 0 and 1 curve, real 0 and 1 waveform at the output. So till then, watch the next video. Thanks a lot. Thanks for watching.